Hello everyone, welcome back. In this session, we will focus on supervised learning, which is one of the most widely used techniques in machine learning. We will discuss what it is, the steps involved, common algorithms, some real world applications, and its advantages and limitations. So, let's get started. What is supervised learning? So, supervised learning is a type of machine learning where we train a model using labeled data. This means the data has both inputs and outputs, or in other words, features and their corresponding labels. The goal is to teach the model to predict the output when it is given new unseen inputs. For example, if we have data about houses, including size, location, and price, or in this case, pri- price, area, bedrooms, bathrooms, and number of storage, we can train a model to predict the price of a new house based on its features. Now let's move on to how to do the pro- so let's move on to how this process works. We are going to discuss the steps involved in supervised learning. Here are the key steps in supervised learning. First, we collect labeled data, which is our input output pairs. Next, we split the data into a training set, which the model learns from, and a testing set, which we use to check the model's performance. Then we train the model on the training data by finding patterns that link inputs to outputs. After training, we test the model using the testing data to evaluate its performance. Finally, we use metrics like accuracy or error rate to measure how well the model performs. These steps form the foundation of any supervised learning workflow. So, what are the common algorithms used in supervised learning? There are several algorithms commonly used in supervised learning, each suited to different types of problems. Linear regression predicts continuous values like house prices. Logistic regression is used for binary classification, like predicting whether an email is spam or not. Decision tree split the data into branches used on specific features. Support vector machines or SVMs find the optimal boundary to separate classes, and neural networks inspired by human brain are excellent for solving complex tasks like image recognition. Choosing the right algorithm depends on the problem you are solving and the type of data you have. Now we are going to discuss some real world examples of supervised learning. For example, spam detection. Algorithms classify emails as spam or not. House price prediction. In this case, models predict house prices based on features like size, location, number of rooms, etc. Next is medical diagnosis. Machine learning can help predict diseases based on symptoms or test results. Next is customer churn prediction. Businesses use it to identify which customers are likely to leave their service. These examples highlight the practical uses of supervised learning in various industries. Here, you can see many other examples where machine learning is used in real world problems. Now, let's discuss about advantages and disadvantages of supervised learning. Supervised learning has some clear advantages and limitations. On the positive side, it can achieve high accuracy when there is enough level data. Some algorithms, like linear regressions, are also easy to interpret. However, there are challenges too. Level data can be expensive and time consuming to obtain. Also, models can sometimes overfit, meaning they perform well on training data but poorly on new unseen data. It is important to strike the right balance when developing these models. So let's conclude this session. In conclusion, supervised learning is a powerful and versatile technique in machine learning. We have discussed its key concepts, workflow, algorithms, applications, and some of the challenges it faces. It is a foundational part of the field, and mastering it opens up new possibilities. Thank you for your time and attention. I would be happy to answer any questions posted on the comment section. Thank you.